Hi, and thanks for watching this video. I'm Nick Reagan, a prospective PhD student in anthropology. I'm currently finishing my master's in historical archaeology at the University of West Florida. What I want to do here in this video is give you a brief overview of myself, my research, and why I'm interested in the New Zealand Ironsands Industries. The title of this talk is Assembled with Sand, New Zealand Ironsands Industries as Frontier Actor Networks. New Zealand has, of course, been a colonial frontier setting up to the recent past. Some would even argue in many ways it still is a frontier. A broad question of my research is how people survived and thrived, or failed as the case may be, in frontiers as a product of the interactions between humans and non-humans, especially metal technologies. I see in the New Zealand Iron Sands an opportunity to explore the historical actor networks of this land, the successes and failures, all the way from the grains to the grand scale of a national industry and beyond. As I hope to show in my research, what we learn about such phenomena is not just descriptive of the past or present, but can also be applicable to future human frontiers yet to be explored. So a little bit about me. You can see here where I grew up depicted by the red star. This was a small town of about 3,000 people named Geneva in the state of Alabama. I spent a large part of my childhood in the forest and creek, as you can see in the image here, which ran behind our house. Now, the name of the creek is Sandy Creek, appropriately enough, and that's also my mother's name. The Green Star is where the University of Alabama is located, where I got my bachelor's degree in interdisciplinary humanities and social sciences. The Black Star is Pensacola, Florida. It's a place I've moved to several times in my adult life, with a brief intermission in Kingsport, Tennessee, which is represented here by the blue star. Pensacola is where I currently reside, and Pensacola says of itself that they have the world's most beautiful beaches, but I'm sure you may disagree with that characterization. New Zealand has amazing beaches, of course, as I've discovered. Here you can see some of the places I've worked and a little more about my academics. I've worked for a small wholesale gift manufacturer, major retail corporations, the U.S. Postal Service, and now the University of West Florida. I've studied both biological and cultural anthropology at the graduate level, perspectives which I apply to my work in historical archaeology. I especially want to emphasize in my research that when we study the peoples of the past, we can learn data which can be applied to current and future human endeavors. I truly see the past as a laboratory of human behavior, which can help us understand societal failures and successes, as the case may be. On the right are some pictures of me actually doing archaeology. In the top left, I'm teaching students on the flotation tank, which is used to separate light artifacts from heavy artifacts. The right and bottom left show some of my work at the Luna settlement, which was the first European settlement in what is today the U.S. in Pensacola, dated from 1559 to 1561 CE. It was certainly considered a major failure by the Spanish, and they did not return there until some 130 years later. Bottom right is a local newspaper article about me in which I link what we're digging up to what they may tell us about human futures. I do enjoy travel. I've been all over North America, although this is my first time off the North American continent. The ruins that you see depicted there on the left are Uxmal in Mexico, dating to some 1,300 years ago. And on the right is Montreal with its French history and a place called The Ring in the CBD. Although we know it's not the one ring to rule them all, it's just a tourist attraction. My research is interdisciplinary. I draw back to my humanities studies from undergrad in the work I do, and of course biological and cultural anthropology. The title of my master's thesis, as you can see, is Metal to Machinations, Nail Production Refinement as an Analog to the Technological Means of Social Control in Pensacola, Florida, 1559 to 1821. I'm studying three archaeological iron nail populations, both microscopically and with X-ray fluorescence, to determine technological changes over that 262-year period. These changes I relate to the ways metal technologies, their exchange, and manufacture affected the frontier people through networks of social control. On the right, you can see a map of the fort at Pensacola that was originally Spanish, then British, French, and Spanish again at the end of the colonial period. The bottom relates to a special project I did on a man named Jonathan Walker, who in 1844 attempted to free several slaves in Pensacola by boat, but was eventually caught. He was punished in part by having his hand branded with a hot branding iron to read SS for slave stealer. Then bottom right is something I'm very proud of. This is an iron wire fishhook I and my crew excavated from our unit in the Luna settlement, which dated from 1559 to 1561. These are so extraordinarily fragile that they rarely preserve in the archaeological record. Thankfully, this one did, and I wrote it up over the holiday break with some of my colleagues. We're calling it the oldest fishhook, European fishhook found in Florida, which means it's likely the third or thereabouts oldest found in North America. Iron fishhooks have been found associated with the Coronado expedition and with the first French settlement in Quebec, predating this one by a few decades. The fishhook is a great transition to my next slide, as this was a crucial technology which acted as a mediator between the settlers and their environment, allowing for survival on what was a harsh, wild land. Actor network theory is the approach that I use to understand the relationships between the people of the past and their social and natural environment. The fishhook as a mediating technology is a great example of this. In A&T, we define, quote, the social as inclusive of not just people, but also all the non-human things we share our spaces with. And we say that objects have agency because we define agency as one body's or object's ability to act on other bodies, objects. Social control then, like agency, is distributed among all actors in a human non-human network, among both the humans and the non-humans alike. Bruno Latour, who you see here, is one of the fathers of actor network theory. He said, quote, "It is always things, and I now mean this last word literally, which in practice lend their steely quality to the hapless society." What he's saying here is that it's not some indefinable overarching categorizations we call, quote, social, or in anthropology, quote, cultural, which act as a glue holding, quote, society together, but rather all the stuff we use and interact with, which provides some solidity to the social space. Where one actor, human or non-human, encounters another actor, we call this an association. These associations alone and in aggregate are what we refer to as the actor networks. In A&T, to study a cultural system, one doesn't start by hypothesizing society-wide categorizations and groupings. One starts at an individual actor and works out from there, describing how the various actors interrelate to form a network. This means an actor network theoretician should be concerned with both the smallest of details and how the grandest of scales are constructed. Scientists, of course, observe through the mediation of technologies like the ones I'm using in my current research, a basic digital microscope and an X-ray fluorescence device, what I call my X-ray gun. The former can show us minute details like the metal graining of the still surface in the bottom image, which we can describe and measure in artifacts over time. The latter, the XRF, can go even deeper and reveal the various elements composing artifacts, like the hand-wrought iron nail you see on the top right. This one is manipulated digitally. It's a technique I've come up with for seeing which parts of the object surface are covered in iron oxides, also known as rust, which you can see in red, and which have the original iron core exposed, which you can see in black. Retained materials are ideal for study with both microscopy and XRF, although I do apply an acid to etch the surface for better observations of the nail structure. You'll note in the middle a picture of the UWF Archaeological Archives. I designed my thesis as a no-dig project, which means I'm only using artifacts from our collections. In the US right now, there's something of a conservation and space crisis. So many students and scholars want to dig that we're quickly running out of space to store every artifact that gets dug up. By studying only artifacts which have already been excavated, I'm both preserving historical sites and avoiding having to store and conserve new artifacts into perpetuity. And this is fine, because there's so much to be learned on these objects that have already been collected. And in a sense, by doing archival-derived research, we're giving forgotten non-humans a new life, so to speak. In particular, I find metal objects absolutely fascinating, and of course, they're crucial for the functioning of the modern world. Technologies made of metal have long played an important role in the social control of populations in frontier settings. Social control is here defined simply as the way in which behavioral conformity is induced in human beings. Items of metal have acted as mechanisms of social order in the often isolated and dangerous frontier settlement that was Old Pensacola and colonial New Zealand and elsewhere. The mining and production of metal objects has been around for millennia. These have shaped society and changed our land and even Earth's atmosphere for thousands of years. In fact, the Romans, in their metal production some 2,000 years ago, changed the Earth's atmosphere in a way that is still recorded in Arctic ice cores to this day. Metals production has been historically and still is a lead contributor to climate change. Metals have these fascinating and useful characteristics. When heated, metal can be shaped and molded into intricate yet strong forms. It's shiny, which people like. It can reverberate with sound. Iron is magnetic, allowing for the creation of technologies like compasses. And of course, the iron sands themselves are magnetic, which is pretty cool. And it conducts electricity, allowing for the modern world to exist as it does. It's not just the use of materials like metal that contribute to our actor networks, but the very manufacture of objects too. It could even be said that making things makes us, like making usable iron from raw iron sands. I propose that control is not just something people do, it's something everything does. If we could visualize social stratification in A&T thought, society looks less like an easy-to-imagine pyramid as on the left, where control is strictly human-derived and unidirectional from, quote, top down, and more like a complicated mishmash of nodes and associations as on the right. These are the networks of actor network theory. Latour says in his book Reassembling the Social, quote, when sociologists pronounce the words society, power, structure, and context, they often jump straight ahead to connect vast arrays of life and history, to mobilize gigantic forces, to reveal behind the scenes some dark powers pulling strings. But the time has come to have a much closer look at the type of aggregates thus assembled and at the ways they are connected to one another. He also says, quote, power, like society, is the final result of process and not a reservoir, a stock, or a capital that will automatically provide an explanation. Power and domination have to be produced, made up, composed. Asymmetries exist, yes, but where do they come from and what are they made out of? Here, we must not think just of larger objects as sources of control, but also the intricate parts which compose our modern technologies. The circuit, the transistor, and the seatbelt screw are also actors. The tiny black iron sand granules that, in aggregate, form the dunes and beaches of the North Island's west coast are each actors with defined properties, which, with technologies, have contributed to human social organization and the construction of entire landscapes and lifescapes. At first it may sound a bit crazy, but I argue that iron sands have behavior. Not because they can think or feel or act on their own, but because they act with their properties. And when interacting with humans in numerous associations, they consequent certain outcomes. On the left is a beautiful scanning electron microscope image of a volcanically derived titanomagnetite granule from Iceland. Top right are images I've taken of iron sands from the Pacific coast of the US. Then below is a grain from Mount Ruapehu. I have collected iron sands on this trip that I've yet to study with my microscope. Note the different characteristics based on their location. The Icelandic grain is jagged and pockmarked, perhaps a recent unweathered volcanic stone. Because their life cycle has involved erosion by friction from land, water, and wind, the beach grains on the top right have been smoothed to a polish and rounded in shape. The Ruapehu granule is old, but hasn't undergone the same transport processes as those above it. In aggregate, the qualities of these grains individually produce emergent superstructures like shorelines and dunes. They also have certain properties which determine how they are processed in their transformation to useful iron technologies, what techniques people have been required to use, and what technologies have been applied. Just as the association of wind and gravity with dunes produces ripples in the aggregate, so aggregated properties of iron sands have created a ripple effect through human iron sand networks. Here you can see volcanically derived aggregates, or andesols, are fairly rare on Earth, with New Zealand barely showing on the map. You can see them on the North Island, but also in small pockets in Northeast Asia, Central Mexico, the west coast of South America, and the U.S. Pacific Northwest. Bottom left, you can see the distribution system of New Zealand iron sands. From both the central volcano field and Mount Taranaki, they have been transported westwardly to the coast, and then shoreline ocean currents have distributed them north and south, a bit north of both Wellington and Auckland. New Zealand is the only place in the world in history that has developed an iron sand smelting industry of any notable size. Ancient Japan had a small industry of sword making with iron sands found there, but that's about it. The mid-19th century saw the first attempts of settlers using New Zealand iron sands to produce iron, but it was a failure for a number of reasons, not the least of which is a product of the properties of the granules themselves. Historically, iron has always been produced from terrestrial or meteoric ores, never from tiny iron sands. To take advantage of the iron sands and produce an industry would require trial and error and new technologies that would mean a truly successful industry wasn't formed until the 1960s. Here you can see the location of the historic Onehunga Ironworks, depicted by the red star, with a picture to the right, and the Taharua mining fields, a bit later, depicted by the green star. Taharua is still in operation to this day. It's currently owned and operated by TIL Corporation, the Taharua Iron Sands Limited. Here you can see the type of machinery used to collect, smelt, and process the iron sands into usable materials like the steel depicted bottom right. Pay particular attention to this rotating excavator in the upper left, as you'll see something similar a little later in this presentation. Depicted on the left is a furnace that was designed for smelting iron sands in 1883. Because this is an unusual substrate for iron production, it required many different types of new technologies, like this furnace, some of which were a bit successful and others that were failures. Top right is a picture of the beach at Waikawau. Bottom right is a group of workers at Onekaka in 1924, among some of the equipment they made and used. This was located on the South Island and was rare for New Zealand in that it was an iron ore facility. Intriguingly, in 1883, an American manager at the Onehunga Ironworks murdered a worker at a local hotel over a game of playing cards. He was sentenced to 14 years prison labor at Mount Eden in Auckland. These networks of control, industrial ironworks, the system of justice, and the prison control network all intersected on the early New Zealand frontier, as we can see in this case. Here are some newspaper articles from the 1880s to 1890s, which talk about the experimentations attempting to produce a thriving iron industry, as well as a listing of various products the ironworks were making at the time. The headline on the top right indicates conflict between workers and management, with the workers striking for higher wages in 1891. It goes to show that the history of this single industry has touched on so many issues of cultural concern. Continuing with this theme, here you see an image of construction plans for Mount Eden, dated to around 1877. Top right, you see a picture at Milford Track, which was built by prison labor from Mount Eden. And on the bottom right, you see iwi prisoners at Mount Eden who had participated in the Dog Tax War of 1898. What do these have to do with the iron sands industry? These are networks of control, industry, and prisons that existed concurrently. We shouldn't think of these as separate social domains, as there are interactions that occurred from one to the other, as with the prior case. And of course, there are environmental effects from this industry besides air pollutants. You can see here just how close this operation is to the shoreline. I believe this is the Taharua iron sands. And now there is seabed mining for iron sands underwater. On the right, we see a transport ship and the various routes which make New Zealand connected globally through its export industries. These are just a few of the species that can be impacted by iron sands industry. The map on the left shows the level of biodiversity in the water around New Zealand. You can see the west coast of the North Island is one of the most biodiverse, not only locally, but also in the world. Bottom right is a species of tiger beetle adapted for life on the iron sand beaches. This is a unique species to the shores of New Zealand. If it's destroyed, it will be gone forever. I'm very much changing gears here. Do you know where this is? This is the surface of Mars. What does this have to do with the iron sands? Well, quite a bit, actually. This is an area of historical inquiry that can be applied directly to the human future. Mars has abundant iron, much of which is in the form of sands. We should also think of Mars as a frontier setting. The new settlers here will need to figure out how to utilize the available landscape for survival, just like the first settlers to New Zealand. The black sand you see in dunes on the top left are volcanic basalt, perhaps full of iron. The red color of Mars is due to iron oxide, or rust, from the high levels of iron in the Martian regolith. You can see the distribution of iron oxides in the map on the top right. On the bottom left is a measure of the elemental composition of Martian regolith by the Spirit, Opportunity, and Curiosity rovers. You can see there's so much iron in the samples that I had to add the tall bars that extend off the original chart. The image on the bottom right should look familiar. Remember that iron sands collecting machine we saw earlier? This is the same idea, but on Mars. So we see parallels, not only Mars as a frontier settlement, but parallels in technology and presumably the type of social structures to be built on Earth 2.0. This is all to say that the past is the present, is the future. And as Bruno Latour once said, quote, technology is society made durable. I hope my future studies in New Zealand can further bring these connections to life. Here are some sources for further inquiry, and of course, many of the sources that I used for this presentation. Thanks so much for watching this video. This is my contact information, including a QR code that links to my academia website where I have all of my papers posted.